All right. This is the Palomar Observatory in Northern California, in Southern California, I'm sorry. It's outside of Los Angeles. Up in the hills outside of Los Angeles. This was built back in the 1930s. At the time in the 1930s, Los Angeles had like 40 or 50,000 people. Wasn't that big a deal. It was like, oh, this is a perfect place. Southern California is great weather. Good place to build an observatory. Now, where Los Angeles has millions of people, all the light and the pollution, it has its problems just because it's not far enough away. So let's talk about observatory. So if you want to have an observatory for optical telescopes, then you have to have a place with ideal conditions. So first of all, what you want is good weather, or a high percentage of what we say, high percentage of clear nights. It doesn't do any good to put a multi-million-dollar telescope in a place if it's going to be cloudy all the time. You would never put it in the Pacific Northwest because it's cloudy a lot. Okay? Number two, you want it to be away from city lights. So we like them about 100 miles away from a city. So they're kind of remote. And most of the best ones now in the world are very remote. So they're hard to get to for astronomers, but it's worth it. Okay? The reason 100 miles is a very good distance is if you have a city over here. So here's the city over here, and all the light from the city creates this glow of light in the air. If you've ever driven into Dallas at night, you can see this glow coming from the sky before you even get there. Well, if you're about 100 miles away, and here's your telescope over here, then that glow from the city is actually below the horizon because of the curvature of the Earth. So 100 miles is not an arbitrary number. It actually has to do with the curvature of the Earth and how far you need to be away before that glow of the city gets in the way. All right. And you also want to make sure there's very low humidity, because humidity is really bad. It makes the air very thick. It makes it hard to see. It also, when it gets very humid, you can get condensation in your telescopes. It's bad for the telescope. You don't want low humidity, okay? You also want the telescopes to be very high elevation, because the higher you are, then the more air that's below you. The biggest problem is the air. So you put it on the top of a mountain, okay? And that's why in Texas, there's the McDonald Observatory, which was actually created way back in, I think, the 50s by a banker, Mr. McDonald, that had a lot of money. He just donated it to the state to build an observatory. Well, they said, well, the only good place in Texas is out in West Texas where there's some mountains. The rest of the state is so flat, and the east of the whole side of the state is full of humidity. So it's out in West Texas, up in the hills out in West Texas. And if you ever get out there, you should go visit it. It's kind of cool. They got a nice visitor center and everything. You can go tour it. It's a very cool place. I've been out there doing observations many times. Yeah? And the other one you want is what we call good seeing. This is kind of a astronomer-invented term. You know, outside, if you go outside at night and the stars are like twinkling like crazy, and they seem to be flickering and all that, that's because the atmosphere is very disturbed. The more disturbed it is, the more the stars and everything seems to twinkle. When stars get close to the horizon, they'll seem to like change color and flicker back and forth. That means the air is very disturbed. There's all kinds of air currents moving around. There's all kinds of pollution and stuff to deal with. What we want is good seeing, meaning the air is very stable. The air is very clean. Okay? And that is kind of an arbitrary thing. And astronomers, before they put in an observatory, will go out to these sites, and for over a year, sometimes several years, they will just look at the night sky and say, hey, is this a good place? Is the air really good? And most of them are actually on the west coast of the United States or out the west coast of South America. Why? Because here's the United States, Baja California, here's South America. Yeah, not drawn to scale, but you get the idea. Here's Hawaii out here. Like, why would I put Hawaii? Well, it's important. Well, what happens is, because of the wind patterns, we get what we call the prevailing westerlies, wind coming this direction at the latitude of 30 degrees, 30 to 40 degrees. And so all that air is coming in over the ocean. Well, if it's coming in over the ocean, then all of the bad stuff, all of the pollen, the pollutants and all that, fall out of the atmosphere as it goes all the way across the Pacific, thousands of miles. And so the air coming in across the country on the west coast is much cleaner and nicer than on the east coast. The east coast, as it goes across the continent, it picks up all the nasty pollutants. And so the air quality on the eastern coast of the United States is always worse than on the western side. Also down here in Southern California and in Arizona is where it's very dry and it fits most of these criteria here. There's also ones in the Andes down here in Chile and in the Atacama Desert, which is just north of that, which is the driest spot on the earth. Hardly any, it rains maybe once every 20, 30 years sometimes. It's very dry, very high, like 10,000 feet or something like that, so it's an excellent place to do astronomy. They've also found Hawaii is a great place. You're like, Hawaii rains all the time. It does, but in Hawaii, they have these volcanoes. And the volcano is very high, about 14,000 feet. And the island actually has like two volcanoes. They have the active one over here and they have the old one over here. This is Mauna Kea. This is where they put the observatory. Where all the telescopes are is up here. Okay? Why? Because it does rain a lot in Hawaii, but all the rain actually stays down here. It never gets up to 14,000 feet. So all the clouds and rains are down here. So up here on the top of the mountain is actually an outstanding place to have telescopes because it's very high elevation, low humidity. The humidity never gets that high. So it's super dry up there. It's not 100 miles away from the city, but it doesn't matter as much because the clouds that come in down low actually block out all the city lights. It's like throwing a blanket over it. Okay? And they get a lot of clear nights, very many clear nights. And the seeing is outstanding because the air quality is great in the middle of the Pacific Ocean. So that's one of the best places on the earth to have telescope. So good that even other countries start putting their telescopes there. Japan wanted to build a national telescope, but they realized Japan was not a good place to put it. There wasn't any place in Japan that actually fit well. So they asked us if they could put their telescope, their national telescope, on the Mauna Kea mountain, and that's where they put it. It's called the Subaru telescope. Subaru, by the way, the car company, is named after the Pleiades, which is a cluster of stars, and so that makes sense of why they named it that. Also, we wanted to do the same thing, because if you have a telescope in the northern hemisphere, you can only see northern hemisphere objects. We wanted to see southern hemisphere objects, so we actually have telescopes down here in Chile, at what's called the CTIO, Cerro Inter-American Observatory. They're actually American telescopes, but we put them down there because we wanted to have telescopes here and here. So there's an observatory in Arizona called Kitt Peak, a national observatory owned by the government, and one in Chile, kind of a mirror image of it. So you, depending on what objects you're looking at, you go to different places. I've been to Chile like 3 times, and I've been to Kitt Peak like 4 or 5 times doing observing. Nowadays, you don't go there anymore. It's not as romantic as you used to. I still use telescopes in both places all the time. I mean, a dozen nights a year or more. We get time on these telescopes. But you don't go anywhere. I just go to my office and I run it from my computer. So it's what we call remote observing. I run the telescope, I open the dome, I do everything without ever actually going there. All right, so let's look at some pictures of some telescopes and observatories. So as I told you, this is the Palomar one. This was built way back in the 30s. This is what's called the Hale telescope inside the Palomar Observatory. And this is what the telescope looks like. Now remember, this was one of the oldest telescopes, old big telescopes. And it has a really big, it has a 5-meter mirror, which is really big, 200 some inches. And at the time, 1930s when they finally, it took them like a dozen years or more to actually build this. It was a major technological challenge. Remember, because even in the 1930s, you didn't really have giant cars and trucks, and you had this huge mirror which you build elsewhere. And look at the giant tubes and all this. So it was a major undertaking to build this thing. But they built it, and it was the biggest telescope in the world all the way into the 1960s. And then the Russians built one bigger, but it never worked quite as well. So it really wasn't until the 1970s that they started getting bigger, better telescopes. But this is a classic old telescope. It's a Cassegrain design. Light comes through here. The dome is closed, but they'll open the dome. Light comes through here, hits the mirror, hits a secondary mirror, comes back here, and all the detecting equipment is on the back of the telescope right here. And sometimes they would even put a camera up here, because you could actually focus the light right up here without bouncing it back through, and you could focus it inside here, and the astronomer would just ride around inside the telescope. These are the currently biggest telescopes in the world. They are building bigger ones, but they haven't completed them yet. These are the Keck telescopes. K-E-C-K. These are 10-meter telescopes. So double the size of the Palomar one, the 5-meter telescope. Now, why do you want bigger size? Well, for telescopes, you want to gather light to see the faintest thing you can. Well, the way to gather light is to get a bigger telescope. So it's kind of like this. You say, okay, I want you to go collect rainwater when it's raining. Here's a bucket. If you have a small bucket, are you going to catch much rainwater? No. So the biggest thing to do is have a giant bucket.